Hi, this is section 2.1 for linear algebra. As you can, well, this is relatively an easy unit, I think, at least compared to those other units that we've had in the past. So I'll just blitz right away, and then we are for part A. I'm hoping to go all the way from 1 to 17. So we'll see how fast we can get there. Okay. So from number 1 to number 4. They deal with these two terms called minors and cofactors. At the moment, it's not very essential as to, to understand what they are exactly. But nonetheless, if you're curious, minor just simply is a determinant of the submatrix. The reason why we say submatrix is, well, you'll find out what I mean. But if you have more than 3, but if you have greater dimension than 2 by 2. So say 3 by 3, which is what we run into, but 4 by 4 as well and beyond. You can't use inverse formula that we're so comfortable with size 2 by 2. So basically, what we do is we use the same method that we use for size 2 by 2, but we go through multiple steps so that we can break down submatrices. And if it's 3 by 3, there will be 3 of them, and vice versa, and so forth. So, yeah. So essentially, we're looking for we're finding determinants within mini matrix that was broken down. Yeah, it's like an inception within an inception. If you'll see what I mean exactly as we go further. For now, though, let's try to appreciate how to calculate the minor and how to calculate the cofactors. For now, okay? So. Alright, so take a look at that question 1. So this is a matrix we're given with. Find me all minors and cofactors. I think it's a bit redundant. I think if you get the big picture, then you don't necessarily have to do all of them. Nonetheless, just follow through. So basically what I've done is for M11, right? So what this simply means is that first one's going to be I and second one's going to be J. And remember, I represents the row, J represents the column, right? Row, a column. That's always the order as far as we have covered so far, right? So because of that, I'm going to actually say, so first row and first column, because that's M11, right? So if we do that, we can get rid of these, which leaves 7, -1, 1, and 4 left, right? So essentially now we're really doing is finding a determinant of that sub-matrix or mini-matrix, right? And we know how to do that when it's 2 by 2, right? So simply, you do A times D minus B times C, right? So I just did 7 times 4, and then minus, yeah, that's poorly written, but that's -1 and 1, right, from these two. So, and that will give you 29. So that's all there is, right? Very similar to determinant, right? So essentially, so picture it that way if you're trying to figure out what minor is. Let's go into cofactors. So cofactors, by definition, is this. Relatively straightforward. So Cij, so equals to -1 to the power of I plus j, and then its respective minor, Mij, right? Because all i's and j's are proportionate, right? So interestingly though, one thing you might want to know is because that is -1 to the power of whatever, right? The number's not going to change. It's going to be always 1 or -1. It's never going to be 2, 3, 4. So basically it determines the sign. That's its role, right? Now how do we know when it's going to be negative and when it's going to be positive? Well, easy way is to just test it out using calculator. But if you want to get used to the system, now this is what you do, right? -1 to the power of even number is going to be 1. -1 to the power of odd number will be -1. So if it's even, you're going to do -1 times well, let's say even number like 4. Then you do this 4 times. So negative, they will cancel out, right? So again, this is a rule I use, but if algebra is not comfortable for you, make sure you carry a calculator and just test the value, right? In case, right? So as you can see, so keeping up with M11, so that's going to be -1 to the power of 2 because it's 1 plus 1, M11 we already calculated from 29, so that's 29. Because negative 1 to the power 2 is going to be a positive number, so it's not going to change the sign. And yeah, so that's all there is. So just for 1 to 4, basically just do it until you're comfortable showing these, and after that you're good to go. It's not rocket science. I've done M12, M3, M23, M33. I think if you can do these, you're pretty good enough to move to the next stage. The solution manual will cover all of them, but again, I think it's redundant, unnecessary, and just waste of time. So, but anywho, so that's that. Moving on to the next one. So number 2. So number 2 is, again, same thing, just using different matrix. So if you feel like you should do a little more practice, at least you have some kind of reference that you can use, right? But for most of us, if you can do 1, 2 should be a piece of cake, right? So let's move on to number 3. This is where it gets a little, oh yeah. Before I get to number 3, this is an important thing I need to mention. The reason why we don't really have to worry about this or this, these system may be familiar to you on your lecture, simply because it's already designed, right? Plus, minus, minus, plus. So that's why plus and plus stays together and minus, minus stays together like that, right? So interesting, right? So really, if we were determining the determinants, this is what it should really be like. So if it's determinant, let's say this was A, right? Then this is really going to be positive, positive. So it's going to be times, times. So this is going to be, what is, so for, let's say we're using this one, right? And it's going to be 3 times 6, because they're both positive. And 6 and minus should really be negative 6, right? Because there's minus here, right? And 1 is also negative 1. It just said negative times negative because you're positive. So that, so it, oh. Yeah, so that's essentially what it is, right? So, yeah, okay. Just wanted to make sure that, yeah, I was on the right track. But nonetheless, yeah, so, yeah, okay, yeah. Sorry, I was trying to figure out if there was a mistake at all. So, because we're going to use this same method to the larger matrix on question 3, right? So, for number 3, we have a 4x4 matrix, which is a little bit tricky, but again, it's the same idea, right? So, first part A is M13. So, we're gonna get the first row. And then the third row. So what's left is these 6 numbers and then 3 numbers here, right? So that number is going to be transferred here, right? So that's my submatrix, right? Here, obviously, it's different from question 1 and 2, right? It's 3 by 3, so we need to break it even further. So this is when what I was talking about when I said inception within inception, right? So in this case, we can't choose the rows. We can't choose the columns. We can only choose the rows. And so basically, you get to, this is where you get to choose. You can choose the first row, second row, and third row. And try to be strategic about this, because it may save a lot of time depending on, what row you choose. The reason why I choose row 1 is because if you notice, it's 0, 0, 3, right? Essentially, you want as many zeros as possible, because when we try to calculate the determinant, right? 0 times anything is 0. So we love that cancellation, right? So, and if you follow with the rest of the question, you will see why, right? 0 times, oh, and another thing, if you write 0 times, some people might say, well, anything times 0 is 0, so why do I even need to keep writing? I just put it at 0. Mathematically, that is correct. I think it's nice that you play on the safe side in case the professor said, well, you didn't show me proper work, right? So I think showing the rest of the correct numbers and matrices, right? It shows you that you know what is happening. So, and you can always just cross them out and put it as 0 afterwards, right? So try to write them all down nonetheless, even if you times it by 0, so they should all disappear. So that's what I have done. And so first 0 and then second 0 gone, right? So we're only focusing on this one. So 3, and we know how to find the determinant of 2 by 2, right? 4 times 1 minus 4. And because it's going to be 4 minus 4, it will be 0. Okay? So if it's 0, so let's try to find the cofactor now. C13, so by that equation we talked about, negative 1, 1 plus 3, right? Now, here's the thing though, n13 is 0, right? So I just wrote it anyway, but obviously the answer is going to be 0, right? So that's all there is. Oh yeah, another thing, yeah. So you might have wondered 0, 1, 0, negative 1, and 3, 1. Like, why is 1 and negative 1, 1? Where is the sign coming from, right? And this is why I was briefly talking about this thing. The same thing applies also with 3 by 3. So, just memorize it this way. It's plus minus plus, minus plus minus, plus minus plus, right? So just make it in alternating order, right? So what happens is if I choose 0, 0, 3, right? The first 0, which position is it on? It's on plus. That's why it's 1 plus. Second 0 is on negative. Therefore, this must be negative. Fortunately for us, both of them are gonna be multiplied by 0, so we don't really care. But it may matter later on. Last one is going to be 3, which is on positive side. That's why it's 3 times 1. That's all there is. Right? So everything else is pretty straightforward. Push, push, push. Okay, C is just a continuation, so this is another example. But as you can tell, I choose 4, 0, 14 again, right? I know 14 looks ugly, but the fact that I can get rid of one component of the calculation completely because of that 0, that's totally worth it, right? So I put it in this format. As you can also tell, this is negative 1, 1, and negative 1, right? Because if you remember this thing, now we're looking at the second row, right? So it's negative plus negative. Negative plus negative, right? So negative plus negative. And that's all there is. And if you calculate it up, it gives you negative 48, right? So that's that. And once you have negative 48 for the minor, we can find the cofactor, right? And this time we know it's not going to be 0, right? So C22, yeah, so just follow through. Yeah, exactly. So there you go. For number 4, it's the same idea. So again, different 4 by 4 matrix, but again, same thing. So I just did B because now it's getting a little redundant. But if you care to try, give it a try on yourself, and then check if you have the same thing as I did. Hopefully you will. You would. If not, either I messed up or you messed up. We'll figure it out soon enough. Okay. So we're on to question 5. All right. So for question 5, what are they asking this time? They just want to determine just find the determinant of the given matrix, right? So if matrix is invertible, use equation to find the inverse. Okay. Well, first part is we have to try to determine whether it's invertible or not, right? So what do we mean by this? Remember, we were trying to figure out what am I saying? Determinant will determine, I know it sounds weird. Determinant will decide whether it is inversible or not. Because remember when we were dealing with the inverse formula for 2 by 2 matrix, right? So I'll just write on here, I guess. So it's going to be 1 over determinant, whatever matrix, let's say A, and this is going to be DA, right? Because A and D are flipped. And BC's aren't flipped, but it's just going to have the sign flipped, right? So remember, that was the inverse, right? So if determinant A, we can't do 1 divided by 0. So that's when we say it is not inversible. So we talked about this a long time ago, but that's a quick review, right? So one of the ways, what we're going to do is to determine the determinant A, right? And then, hopefully it's not 0. If it's 0, you should say it's not inversible, right? If it isn't 0, then, we should be able to hopefully find the inverse. So, let's take a look at here. So, first one, number 5, 3, 5, negative the 2 and 4. So, determinant is pretty simple, A times D minus 5 times D. And that gives you 22, which is not equal to 0. This means it's inversible. For the same reason we talked about here, right? So let's move on. So it's going to be A inverse is going to be 1 over determinant A, and I think I already switched, right? So A and D, so 3 and 4 switched, and then 5 and negative 2, the signs are flipped. And then it's going to be 1 over 2, 1 over 22, right? Because the determinant was 22, right? So times them together, and then you have this nice fraction entries of the matrix. So, anyways, that's the answer. Let's try looking at number 8. This one's a little bit weird because it's got square roots, but again, it's the same idea, right? So, determinant A, so square root 2, square root 3 times them together, minus square root 6 times 4. So, the only thing, so what happened is 2 times 3, so that gives me negative square root of 6, and then square root of 6 times 4 is going to be just 4 square root of 6. So for people who are not comfortable with algebra, so there's an imaginary 1 here, right? We just don't write 1, right? So because of that, so it's going to be like 1 minus 4, that will give you negative 3 square root of 6. It's a negative number, sure, but it's not 0, so it's inversible. Which means we can go ahead and try to determine the inverse, right? So then it's going to be inverse, 1 over determinant, and that. And this is where math gets a little nasty because of the square roots. But again, just follow through. These are mostly algebraic, so, hopefully you get what I get. But, yeah. So, a few things to explain maybe. So 4 is, for example, there's a 4 here, right? So, 4 is the same thing as square root of 16. So, and then here I just broke down square root 3, 2, so that I can cancel out that 3, and so forth, right? For this one, it cancels nicely. Here I did that same thing, square root of 2, square root of 6, right? So I want to get rid of the square root of 2. You don't have to, I guess, but I want to do. So square root of 6, I become square root of 2, square root of 3, because they're the same thing, and then I can cancel out the 2. So ultimately, I get this. So try it on your own, if you'd like. This is where it gets a little more interesting. So this is going to be question 9. So in this time, we're going to be using an arrow technique to evaluate the determinant. So visually, it looks really easy. Actually, it is. But you just have to be a little bit tricky because of the signs and the lot of numbers that you're multiplying, so to speak. So let's take a look. Number 9, so we have that 2 simple matrix. So when you have simple 2 by 2 matrix, just think of arrow as going this way. So arrow to the right, arrow to the left. Crossing 2, crossing 2. So what I do is the left side is the negative and the right side is the positive. So arrow going this way is going to be positive. Arrow going the other way is going to be negative. So A minus 3 and A minus 2, right? So they're going to be times them together, and they're going to be positive, right? That's why there's no sign change. Here, though, it's going to be 5 times negative 3, but it's negative, so there's going to be negative in front. So, rest is just algebra, right? So I'll let you decide how to do that. You don't really have to factor this. I suppose you could try. Maybe it won't factor, but yeah. But all it's asking is determinant A. So it's not asking what A is, right? Anywho, number 10. So this time we have 3 by 3 matrix. So here's a trick that you want to use if it's 3 by 3, right? So look at the first and the second column and just copy and paste it up here. So that you have 2, 7, 6, and then you have the 2, 7, first and second column repeating again, right? So, and basically what you do is, after that's set up, you want to do this. So basically, if the arrow is going towards right, that means it's positive, right? So because of that, it's going to be, and also because it's 3 by 3, we want to make sure whenever we have an arrow, there's 3 components, right? For 2 by 2, there was only 2 to do, right? But for this matrix, it's got to be 3. So we can't choose 5, 8, or 3 because 3 is just 1 entry, 5 and 8 is 2 entry. This is where we can start because there's 3 entries, right? So 2, 1, 4, 7, negative 2, 3, 6, 5, and 8. Those are going to be all positive because arrows are going that way. If the arrow goes the other way, it's going to be negative. Notice that 8 we couldn't use because there's only 1 entry. 1, 3, there's only 2 entries, so this is the earliest we can start. So what are we doing with these arrows? So essentially, let's start with the plus 1. So 2, 1, 4. 2 times 1 times 4 plus 7, negative 2, 3, 7, negative 2, 3, plus 6, 5, 8, 6, 5, 8. So these are the positive forces, right? Let's look at the negative ones, right? 7, 5, 4, so, sorry, okay, I started from this arrow, so 3, 1, 6, 3, 1, 6, but it's going to be negative in front, right? Next one, 2, negative 2, 8, 2, negative 2, 8, minus in front, right? 6, 1, 3, oh yeah, sorry, 7, 5, 4, 7, 5, 4, minus in front because that's a negative. So then you just clean this all up algebraically and then you get 80, right? So, and number 12 is essentially the same thing, right? It's the same idea, right? So, yeah, there's really nothing more to say. This time I just didn't bother writing it this way because I can still do it without separating the arrows apart. So this may look a little confusing, but again, it's the same idea, right? So if you get lost because of the arrows overlapping, do it this way. It doesn't take that long to split them up like that. Yeah. So and how big the penalty is when we make mathematical mistakes, right? So better to do this and get it right totally rather than doing that, unless you're comfortable doing that way, right? So you decide, right? Anyways, so that's how you get the determinant. Next one's a little bit weird, but again, it's the same idea. It's the same idea. The only difference is some of the numerical entries are replaced with c's and c squares. But again, it's the same idea, right? So I segregated them. So get the first two columns, put it up there, minus, 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 plus, 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 and then we just do the same deal. So it is a little messy, but this is what I get. And we don't have to factor or find the c. That we will deal with a little later, which will be in the next question. But anyways, for 14, this is what you get, right? So, just if you want to try this one out, see if you get the same answer as me. Question 17. So this time, so for 15, 16, 17, and technically 18, I haven't done 18 because they haven't specified, but nonetheless. So in this specific area, you're gonna be looking for a determinant just as we have been doing. The only difference though is that this time they actually say the determinant is always going to be 0. So let's look at this one. So we use the same method, positive, negative, and we do that, and then we have lambda squared minus 1 equals 0. Because determinant A is going to be 0, right? Then what value of lambda must it be? So I just factored it out, and it's going to be plus or minus 1, right? Good. So that's a simple one. It gets a little bit more tricky when we do question 16. Okay, so this is question 16. So again, it's the same idea, right? So we just simply did the arrow method again. But this is where it gets a little bit tricky. So basically what I've done is, as you can see, there's a lot of weird things happening, right? Because there's a lot of expressions multiplying with numbers and another expression. But good thing is there's a lot of zeros. So this may look a little overwhelming, but anything with 0, like this, all just gets filtered out, right? So you're left with this, essentially. But remember, that they did say for this question determinant is 0, right? So all I did was here, rather than trying to just multiply this and simplify, to me that seemed like too much work, right? So all I did was I actually got this negative side and then moved to the right because there's a negative in the front, right? I think this one's this one, right? Negative in front. So I just did plus this expression to cancel it out, and then so you're gonna have this thing equals to this, like so, right? Hey, beautiful. I see one that could cancel out right away. So if you cancel it out, the expression becomes so much more manageable. So you have square root of -1 square, what am I saying? Lambda minus 1 times lambda. Where did -6 come from? There's a 6 here, right? So if you cancel this one out, then there's only 6, so you can do subtraction. You don't have to go through division, right? So subtract 6 on here, and then you have this expression. Hey, look at, you guys can see that, yeah? Yeah, good. Yeah, and look at that. That's a nice quadratic example, right? So then we are going to factor it out, and so lambda values are 3 or -2, right? So again, not too difficult. Just be comfortable with so that you don't get blissed on the test, right? So that's done. That concludes part A. We will finish the rest in part B.